So today I'll be talking about can we guide light by making tiny tunnels. In particular, I'll be talking about can we create optical light highways using ultrafast lasers. I'm Abdullah Tamim, and I'm a fifth-year electronics electrical engineering student. So let's do an exercise. I don't really do much exercise. So how fast can you blink? Oh, there's a lot of blinking going on. Who's cutting onions here? So, well, you can blink between 0.1 to 0.4 seconds. You might think that is very fast. I kind of think it's very fast. But what if I told you there's something much faster, a laser that is way faster, right? How fast do you think ultrafast is? All right, let's see how many zeros there are. 2. Oh, 0.0000. Any more? Woo! Even my poor bank balance doesn't have that much zeros, right? So that's about 15 zeros for 1 femtosecond, and that was the laser that I used. Just before I go into more details of the process, this is basically what I did in the lab, using a laser to write. Very cool, very good. I don't know why they gave me a laser that can kill me, but you can do very cool things, and I hope to share that to you in this day. So what do you think I mean by light tunnels? Now, when you think about tunnels, what do you think? When I'm driving in a road from one place to another, I think it connects things up. It's the same way light tunnels are. In technical terms, we call that waveguides. Waveguides are basically structures where you have two different structural difference, and because of that refractive index, you can guide light from one end to another. And this has a lot of applications, especially if you are working in photonics. So what is ultrafast laser inscription? Now, I've told you about ultrafast lasers. They're very fast, faster than when you can blink. Told you about light tunnels. Now you'll be like, Tamim, you're an engineer. Why are you just talking about lasers and talking about tunnels? What's the application? Oh, I'm sorry. Okay. So the application of ultrafast laser inscription is microfabrication technique. Now, microfabrication means, microfabrication means making things very small. Now, I'm a small person, so yay, we like to make things small. But there is also, in the world of technology, we're trying to make chips smaller, 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 so we can fit more and more power and make our computers and phones faster, faster, faster. The world of technology. Right, so this is just an overview of like what I mean. In ultrafast laser inscription, you have a sample, the transparent thing. Well, I like to take credit for this. I did this in Microsoft PowerPoint. Well, if you need any creative artist using Microsoft PowerPoint, you can come to me. So that's the that's a glass sample in transparent. Now, if you use a laser, you can write inside. You can write different depths and then different shapes and different patterns. Now, that's all cool and stuff. But what is the coolest thing? So now, I have not prepared for this because this is my first time to do this, and my mom was saying, sorry. My mom was saying, why, when you're fasting in Ramadan, are you taking a donut to uni? Well, let's take an example. If I wanted to fill the custard inside this donut, how do you think you can do it? No takers? Well, well, too expensive, but yeah. But that's what they actually do. They want to fill a custard, they make a hole, right? So you can probably say, oh, let's just dig a hole through the end to end. But that's not what I did. I actually wrote it from inside without actually destroying. Now, if I were to say, I have a laser, and I did this, whee! Oh, sorry. Don't worry, this is expired. No, say no to food waste. Yeah, that's one favorite pencil too, but it's okay. My laser doesn't do that. It doesn't actually damage the glass sample because the cool thing about the pulse laser, the one that I was talking about, the fast laser, it can write inside without damaging. But what happens is you can specifically choose where to damage or cause changes so that you can create those light tunnels. Now, let's go to more scientific explanation. So how does it work? Basically, so you have a transparent sample, you put a laser, you put a laser and you're shining it through the sample, you're making some changes, blah, 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 fancy science stuff. Electrons get very excited like I am, and they change the properties in the material. proper term, my supervisor said to say this, it's called densification, so that I don't sound like a comedian, but an engineer. Then you make some changes inside the glass sample, which causes a hot electron ion plasma transfer, and so you actually make those waveguides, and you change the refractive index. Then, depending on the different laser energies, you can make different types of things, but that's so boring, I don't even understand it after 6 months of doing this, so let's move on how it looks like. So how does it look like? This is, yeah, it looked much better when I did it under a microscope. So because you've made a change within that structure, because of that laser, you have allowed a refractive index change, so that when light goes, it gets guided. Whee! But then there is also the effect of science. It's not perfect. You can always have damages because not everything is controllable. Now, I did say, this is an area to look into. Now, I did say, what is the application? After all, we were trying to make money, but we can also save cost. Faster microfabrication. What is faster microfabrication? Well, University of Glasgow, especially School of Engineering, really likes the JWNC. The JWNC is a clean room where, unlike your level 4 virus center, we also get to wear suits, but we don't need clearance as much if you get trained. Sorry, bragging right. I say we, but they don't actually let me in, but it's okay. So fabrication is very expensive to use. You have to spend a lot of money and trainings, expertise, and also chemicals to do it. But this ultrafast laser inscription can actually solve that problem because you're actually microfabricating by changing and at micro scales without any complex processes. Second thing, you can use this into making integrated photonic circuits. One of the things that the world is looking into, especially NVIDIA and everything, everyone with the big money with AI, how can we go faster because we are not fast enough? So we can also try to make things called integrated photonic circuits. And this is the initial idea where you can make waveguides, allowing light to be guided through chips. Oh, I'm done. Thank you very much.